Hello everyone, myself Dr. Hazari Naresh, working as an assistant professor in Mechanical Engineering Department, VIGNANA VJEC. Today's topic is kinematics of machinery subject and topic is mechanisms and machines. Okay, let's move to. So here first we discuss about this what are general topics when we are starting this kinematics of machinery. So that we are kept into one. So here mechanisms and machines, elements or links, classification, rigid links, flexible and fluid links, types, and here turning, rolling, screw and spherical pairs, lower and higher pairs, closed and open pairs, constant motions, completely, partially or successfully constant motions, and incomplete constant motions. This is the first half part. Second half part is mechanisms, machines. Here the classification of machines, kinematic chains, inversions of mechanisms, inversions of quadratic cycle chain, single and double strider crank chain, intermittent motion mechanisms. Next. So in overall this unit 1, we are going to discuss about these 5 parts. First one is link, kinematic pair, kinematic chain, mechanism, then finally machine. Let us move to the first part, links. Now in general, what is a link? Link is nothing but it is a machine part, or we can say that it is an element, it is a member. We can define anything. So which moves relative to some other parts. It is nothing but it is an element or link. It is nothing but which is connected between 2 parts. The main purpose is to transmit some motions from one part to the another part. Just it's like a member. So if you consider a steam engine body, okay, steam engine, here various elements are there. Let us consider cylinder, say element 1, or you can say link 1. Piston, it is one link. Piston rod, okay, bearings, crossset, everything, these all are considered as an element which are separate purposes, but it is combined, this it is a link. One link is connected to the one link to the another link. Next, here types of links. Generally the first type is rigid link. Rigid, namely itself rigid, okay, the body is to be rigid. Here connecting rod, it is completely rigid body. If any deformation occurs in this body, then ultimately what will happen? Your machine will fail. So there is a no deformation process. A rigid link is one which does not undergo any deformation while transmitting motion. It is completely fixed body. Okay, it is like connecting rod, crank, piston, etc. Next, flexible link. Here there is some flexibility is there. Consider a chain or belt. There are some flexibility is there. If there is no flexibility, then what will happen? It will ultimately breaks. It will not work. At that time, the flexibility is required to transmit the motion from one end to the another end. So that's when we are going to adjust the chains in our bike. So here flexible link is one which partially deformed in a manner not to affect the transmission of motion. Not to affect the transmission of motion means the partial deformation is occurred, but it will be okay. There is nothing will be affect on main purpose. That's called as a flexible link. Here belt, rope, chain drives, transmission, tensile force only. Okay. Next, after that, one more is fluid links. Name itself fluid. It works with the help of some kind of fluid, like some hydraulic. You can say that hydraulic applications, like hydraulic JCBs, lifters, many applications are there. So here this link is one that deformed by having fluid in a closed vessel, and motion is transmitted through the fluid by pressure. Nothing but Pascal's law, as we know. Now it is examples are hydraulic presses, jacks and brakes. These are the few examples. These are the types of links. Next, structure. What is structure? When many fixed links, means rigid links are fixed one another, it becomes a structure. So it is an assemblage of number of resistant bodies. What is resistant? It's going to resist. A body is to be resistant body if it is capable of transmitting the required forces with negligible deformation. Very negligible deformation. That's a resistant body. Number of resistance bodies having no relative motion between them. It's like our bridges. Okay, these are best examples of the structures. Means all the fixed links are going to connected one another. Then it becomes a structure. Like table is a structure. Like here examples are railway bridge structure. There is a no moving parts, roof truss, machine frames, buildings, aircrafts, skeletons, okay, dams and bridges. These are some structural parts. Okay, next part is kinematic pair. What is this kinematic pair? Now pair, as we know, in combination of two parts, we can say that pair. So the two links or elements of a machine when contact with each other are to said to be pair. It is a kinematic pair. In the contact, when two links are going to contact with each other, then we can say that kinematic pair. Now the thing is that the relative motion between them is completely or successfully constrained. The pair is known as kinematic pair. Now the question is, what is completely or successfully constrained? That we are going to learn. Let's see. Connected. One connection. From here to here, one connection. Okay, these two becomes a pair. Skeleton is part 1, part 2. Let us consider element 1, element 2 are connected some means. Then we can say that is a pair. Next, the question is successful, completely or successfully constrained motion. We are going to learn. Next, first one here, types of constrained motion. Here 3 types are there. First type is completely constrained motion. By seeing this figure itself, we can able to know that here part 1, let's say square bar, square hole. A square bar is fixed in square hole. What motion is there? Only sliding motion. Other than sliding motion, any motion? No. So only one motion is restricted. So completely constrained motion, when the motion between pair is limited to defined direction, means particular only one direction here, defined direction, irrespective of the direction of the force applied. If you are going to apply force like this, irrespective of the force applied, so only motion is only one kind of motion. It's only sliding motion. Okay, the motion is said to be completely constrained motion. Example, piston and cylinder. Okay, we have seen piston and cylinder. Inside the piston inside cylinder, only one motion, moving to and fro direction. Collar bearing, it's also only one motion. Next, second one, incompletely constrained motion means it is a incompletely constrained. Constrained means only one. Here incomplete means one motion is not there. There are other than one motion. So that's why we can say that incompletely. So what is incompletely constrained motion? See this figure. Here one square bar, okay, inside this circular shaft. In this condition, two motions are possible. One motion, rotation motion. Transitory is a rotational motion. It is called as a incompletely. So when the motion between pair takes place more than one direction, it's called as a incompletely constrained motion. Then the motion is called incomplete constrained motion. Circular bar or shaft in a circular hole. Two motions are there. That's why we call as a incompletely constant motion. Third type, successfully constant motion. Here what will happen? So the motion is there, but the motion is again restricted. How it is restricted? Just see, successfully. Here, when the motion between the elements forming a pair such that the constant motion is the constant motion is not completed by itself. It's called as successfully, but by some other means, then the motion is said to be successfully constant motion. For example, here footstep bearing is here. A motion in a shaft in a footstep bearing as shown. The shaft may be rotated in a bearing or it may be moved up and down. There's a particular distance, okay, particular direction, moving to this direction. That is a restricted. It's called as a successfully constant motion. The motion of an IC engine, IC valves, that we know, IC was always moving up and down, okay, but here in this motion which is tries to move in this direction or which tries to rotate in this direction, but the direction is again restricted to only specify, okay, with the help of some springs. This is called as again successfully constant motion. So these three motions are very, very important for study the or to simulate this analysis. Next, classification of kinematic pairs. Now, first, according to the type of relative motion between the elements. Now, first one is sliding pair, namely itself sliding. One body or one element slides over the another element. Simple. So two elements of a pair are connected in a such a way that one can slide relative to the other. So for example, if you see lift, okay, in the lift there are some guideways are there, like these are the guideways. The lift will move in between these guideways. Now here the sliding will be happen. This type of pairs are called as a sliding pair. Now piston, cylinder, again piston also moving inside cylinder. Cross head and guides of reciprocating steam engine, and ram ends guides in shaper machine, tailstock on the lathe bed. Okay, these are basically sliding pair. Okay, piston and cylinder, again it's comes to successfully constant motion, but the basically it is a sliding pair. Okay, next, second one is turning pair. Here cycle wheel, see this, here the turning motion is happening. What will be there? When two elements of a pair are connected in such a way that one can only turn or revolve, about a fixed axis of another link. So here axle is there, inside one axle is there, like inside one axle is there. On there we are going to connect to the hub. Here this hub is on this axle which is revolving, which is nothing but turning, which is inside there some balls are there. It's a turning pair. So crankshaft in a journal bearing, lathe spindle support in a headstock, and cycle wheels turning over their axle. These are the two types. Next, one more type is rolling pair. Rolling means one which roll over the another. The best example is ball bearing. When the two elements of a pair are connected in such a way that one rolls over the another fixed link. Cage, inside the cage, which is running inside the cage. Okay, the pair is known as rolling pair. So ball and roller bearings are best example for this rolling pairs. Next, screw pairs. Screw means nut and bolt. Nut and bolts. How these two are going to fix? With the help of helical grooves. Here with the help of some helical grooves. So nut is on this bolt. So you see here, when the two elements of a pair are connected in such a way that one element can turn about the other by screw threads like helical grooves, the pair is known as screw pair. Okay, the lead screw of the lathe with nut that we already know, that is nothing but screw pair. Okay, bolt with nut are the best examples. Okay, next, spherical pair. Spherical, like ball. For example, this joint, this is our spherical joint. Okay, a spherical pair. We can move in this direction, move in this direction, can move in this direction. Like spherical base. The best examples are pen stands. You know what is this spherical pairs? When two elements of a pair are connected in such a way that one element turn or swivel. Word turn or swivel about the other fixed elements. So here, this is known as a spherical pair. The example is ball and socket joint, attachment of a mirror or bike side mirror. This is also spherical pair. Next, according to the type of contact between the elements. Okay, there are two elements are there. What type of contact? Based on that, again there are lower pairs and higher pairs are different. First one is lower pair. Here, when the two elements of a pair have a surface contact, the word is lower means surface contact. Means what are the surface contact? Sliding surface, turning, screw. These all are surface contact. When the two elements of a pair have a surface contact, when relative motion takes place and the surface of one element slides over the another surface, the pair is formed known as lower pair. It will be seen in that sliding pair, turning pair and screw pair. Generally these three kinds of pairs are comes under the lower pair when surface contacts are there. Next, higher pair. It is nothing but line or point contact. Then what is line or point contact? Here if you see this, gears comes on line or point contact. Belt drives, rope drives, or a simple a wheel rolling on road, it produce line or point contact. Now what is this? When two elements of a pair have line or point contact, when the relative motion takes place and the motion between the two elements is partially turning and partially sliding. This point is important. Partially turning, partially sliding. So here this will happen. When there is some skidding is there, then partially sliding. It is skidding. Now rolling. So here also rolling. Here it consists of rolling as well as sliding. Here also two. Partially turning, partially sliding. So this type of pairs are called as a higher pair. So the examples of the pairs of the friction disc, it's also turn as well as slide, both will be happen here. And gear tooths and belt drives and ball and rollers, this all are fall under higher pair category. Okay. Next, according to the type of closure. Here, what type of closing are there? Those pairs. Based on that, again there are two types. One is self-closed pair, forced closed pair. So what is this self? Sliding pair, turning pair, screw pairs. Here the simple is no external force is required to make the pair in closed manner. So when the two elements of a pair are connected together mechanically in such a way that only required kind of relative motions occurs, is known as a self-closed pairs. Means simple external force is not required. Automatically see here. Let's say here any external force is required to make this joint. No, once its joint is fixed, always fixed manner. Screw, once we are going to wound on this bolt, is always fixed. No external force is required. Those kind of pairs are called as a self-closed pair. Now, what is forced closed pair? Here simple is external force is required to make the pair in closed manner. Like forced closed pair. So we have force closed pair. When the two elements of a pair are not connected mechanically but are kept in contact by action of external force, the pair is said to be forced closed pair. For example, if you are going to attach the cam, we are going to keep cam in this direction. Now we are going to rotate this cam. Will this follower moves in this direction? No, it will not move. It is in constant mode. But the same follower, if you are going to keep here, then the follower moves up and down motion because of the self weight is acting on this cam. Means there is some like gravitational force or some self weight is required to maintain this pair is in closed shape. That's called as a force closed pair. For example, door. Consider this. In this door, if you are going to open this door, always it's in open manner until unless you are going to apply some external force. So some external force is required to make this in closed manner. This is called as a forced closed pair. Okay. Next. Now we are moving to kinematic chain. What is this kinematic chain? So when the kinematic pairs are coupled in such a way that the last link is joined to the first link. Last link is joined to the first link to transmit the defined motion. And it is in completely or successfully constant motion. It's called as a kinematic chain. A simple 4-bar mechanism. So link 1, link 2, link 3, link 4. Now last link is connected to the first link. Okay. See. Joined to first link to transmit the defined motion. This is called as a kinematic chain. Simple. Next. Here various links are there. This we will discuss later. Now, types of links based on attachments. So first one is binary. Name itself binary, having 2 connections. Ternary, 3 connections. Quaternary, 4 connections. So yes. So let's consider this is from element 2 to 3. It is binary. This is binary. Okay. This is ternary. Ternary. Now, binary links, ternary links, quaternary links. Here, this is a binary, only 2 joints we can make, maximum 2 joints. Now, in this link, 3 joints. It's ternary link, 3 joints. Okay. Here 3 joints, here 4 joints. 1, 2, 3, 4. It's a quaternary link. Next, types of joints in a chain. So joints, here we are going to discuss about these joints. Binary joint. So when 2 links are joined at the same connection. Okay. So for example 1 and 2. Here point B is a binary joint. Only 2 connections. Like 4-bar mechanism. 1, 2, 3, 4. 4 binary joints. Now ternary joints same 3. Ternary means 3 links are joined at the same connection. is known as a ternary joint. It is equivalent of two binary joint. One ternary joint is equal to two binary joints. For example, in right side figure, okay, there's three binary joints A, B, D. Okay, next, and two ternary joints C and E. C, sorry, E. Two ternary joints here. 1, 2, 3. 1, 2, 3. The ternary joints. Since the ternary joint is equivalent of two binary joint. Okay, this is one. Next, quaternary joint. Here, 4 links. So when 4 links are joined at the same connection, 4 links are joined at the same connection, we call as a quaternary joint. For example, consider the chain mechanism. So it has one binary joint at D point. So you see D point, link 5, link 4 are joined at particular point D. It is a binary. So 4 ternary joints. So where A 1, 3, 11, B 2, 4, 1, E 5, 6, 8, 7. Next, F 6, 8, 9. 3 links. Next, 2 quaternary joints means 4 links C and G. C and G. C. Here link 2, 3, 10, 9. 4 links are connected. And G 7, 8, 10, 11. These are the quaternary joints. Okay. Next, based on these links and joints, so here one relation is made. The another relation between the number of links and the number of joints which are constitute kinematic chain is given by the expression where J is equal to number of joints, L is link, J is equal to 3 by 2 L minus 2. Now, how this will form? For example, by seeing this, is there any relative motion? No. You can say no. Why? Because link 1, 2, 3 all are fixed. It is like ternary link. No, that's fine. So J is equal to number of joint 1, 2, 3. 3 joints 3 by 2 and number of links 3. 1, 2, 3, 3. So 3 is equal to 3 by 2 into 3 minus 2 is equal to 2.5. So where LHS is greater than or equal to 2.5. So LHS is greater than 2.5. So such type of links, so no relative motion is possible. Such type of chain is called as a locked chain and forms a rigid frame or structure which is used in the bridges trusses. So you observe these bridges structures like this, they are going to made in this form. Okay, it's called as a no motions is possible in this kind of structures. Okay, once see, it's a locked chain. Now let's see next. One more is same. Let's consider 4-bar mechanism, 4 links, 4 joints. We are going to substitute the same. J is equal to 3 by 2 L minus 2, where if you are going to do this, then you will get LHS is equal to RHS. 4 is equal to 4. such type of chain we call as, hence it may be called as a constrained kinematic chain. Constrained kinematic chain. What is this constrained kinematic chain? It is base of all the machines, means it's going to form only one motion. If there is some input is there, some output is produced. It's called as a constrained kinematic chain. Constrained, successfully constrained, okay, completely incomplete constrained, we have discussed now. Same, is a constrained only one possible motion, like 1 degree of freedom, for example. That is possible with the help of 4 bar. Next, let us see one more chain. So it is based on 5 links. So I say if you're going to form this again 5 joints, 5 links, then LHS is less than RHS. Then what will be happen? Such type of chain is called as an unconstrained chain. Unconstrained means more than one direction. If there is some input is there, there are 2 different outputs are produced. It is not constrained. It is unconstrained chain. So basically this we are not going to use most of cases. Only few examples are that we will discuss. The relative motion is not completely constrained. This is called as a unconstrained chain. This is because of 5 links. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.